Hi everyone, and welcome back to the channel. In today's tutorial, we are going to discuss into the world of AC to DC conversion. Specifically, we are going to learn how to simulate a full wave bridge rectifier circuit using the LTSpice. Now, before jumping into the simulation, let's quickly recap the bridge rectifier actually what it does. We have a AC input signal. Think of it as this way line going up and down, and our goal is to convert into a DC signal, which ideally would be a nice steady line. The magic happens thanks to these four little component. This is our diode. Remember, diodes are like one-way streets of electricity. They only allow current to flow in one direction, and in the current circuit, we are using the diode, the part number called 1N4007. Now, watch closely as we stimulate this. During the positive half cycle, our AC input, the current flow from the source to diode 3, and then through the load resistor R1, and finally back to the diode D4, and it goes to the other side of the source. Notice the direction of the current flowing through the resistor R1. See here, it start from source and go to the D3 and go to the resistor R1, and again it go to the D4 and the source. The current is in this direction. Now when the input goes negative, okay, from here to here, current now flows through the diode D1 again through the our load resistor R1 in the same direction, and back through the diode D2 to the source. See that even through the input voltage polarity has flipped, the current through the load resistor R1 is still flowing in the same direction. This bottom trace here, a green color, is our input AC signal. You can see it's a nice 50 hertz sine wave with a peak voltage of 230 volts. Now look at the blue color trace. This is the voltage across the load resistor, our rectified output. Notice how the negative portion of the AC waveform have been flipped positive side. This is pulsating DC. It's a step in the right direction, but it is not a smooth DC signal yet. So how do we smooth this out? That's where the capacitor comes into the picture. Let's add the capacitor in parallel with the load resistor R1. Now run the stimulation, and we need to check the voltage across the load resistor and see what happened here, and look at the red trace is now how much smoother. Here the capacitor acts like a temporary energy storage device. It charge up when the rectified voltage is high and then discharge when it start to drop, effectively filling the gap and reducing the ripple. We can see there is still a little bit of ripple. We can reduce this by increasing the value of the capacitor. Let's try that now. For example, I am using the 200 microfarad. So now I am going to run the stimulation. See how our ripple got reduced. Fantastic. As you can see, a large capacitor gives us a smooth DC output. Of course, the ideal capacitor value depends on the specific application and the load current. So there you have it. We have successfully simulated a bridge rectifier circuit in LTSpice. Even added a filter capacitor to smooth out the DC output. This is a fundamental circuit in many electronic device, and understanding how it works and how to stimulate. Don't forget to download the LTSpice software. It is a completely free. And also, if you found this tutorial helpful, please give a thumbs up and subscribe for more electronic projects and simulation. Thanks for watching. I'll see you in next video. Thank you. Thank you for the watching.